Andreas Dilger from Intel, and today I'm talking about features that are on the near-term horizon. So these are, appearing in the next, 2 or 3 releases, and most of the things that I'll talk about are already under development, but a little bit of future work. So the 2.12 roadmap is already fairly well underway. We started the feature landing window has started after 2.11 was released, and so many of these things have already been under development before 2.12 opened up, and I'll go through each of them, with a slide, and because there's presentations on some of these topics already, I'm not going to spend a huge amount of time on the ones that already have their own dedicated project. But as you can see, 2.12, there's already a number of interesting features appearing. Some of them are, continuations of features that went into 2.11 to, either optimize performance or, improve the usability and things like that. There's some new things coming in. 2.13 and 14, more ambitious projects going in there that will take, some months to develop, and so they won't be ready. I mean, like with all of these features, the landing into a specific release is our, best estimate of when they'll be available, but, it depends on, how the feature, if it's ready by the time the feature window is complete. We're looking, in terms of time frame, we're looking at about 6 to 7 months from now for 2.12, and each of the 2, 13, 14 windows, we're estimating about 7 months of development and testing time before each release. So one of the first things that is going in, LNet Network Health. This is a follow-on from the LNet Multi-Rail project that was landed originally in 2.10. In 2.11, we got a feature called Dynamic Discovery, so that if 2 nodes connect to each other through LNet, and they see that they're sharing the same network interfaces, the same physical network, they will automatically configure LNet Multi-Rail. Like in 2.10, the feature was there, but you had to configure it. 2.11, we got Dynamic Discovery. 2.12 has Network Health, and that will help monitor the interfaces and be able to do LNet level message resending. Amir will talk about this in more detail. So Data-on-MDT is again a feature. It went into 2.11. It's one of the things that people have been interested in for quite a while to improve the small file performance. And to be clear, I mean, the Data-on-MDT helps small files. It doesn't help like small I/O, which is a completely separate problem. But at least this, according to statistics that I've seen for at least a lot of the large labs, and I think it's true all around, that like 90% of your files are less than a megabyte in size. So even though 90% of your space is consumed by about 5% of your files, 90% of the number of files can fit comfortably in about 5% of your space. So right now, I think MDTs are typically about 1 or 2% of your total file system size. I think you bump that up a couple of percent, and then you can fit almost all of your small files directly. There's lots of performance improvements because of reduced RPC counts, different storage type, flash versus disk, RAID 1 versus RAID 6, right? So there's lots of benefits. There's a whole presentation on this, so I won't get into too much detail. Oh yeah, another area that ongoing saga, if you want to call it that. So the DNE features, we got DNE2 stripe directories a little while ago, and one of the hard things about adopting DNE2 today, I mean, DNE1 is fairly straightforward. You got remote directories, and you can distribute your namespace in a fairly static manner across metadata targets, by creating subdirectories or subtrees that live on different MDSs. DNE2, we had stripe directories, which is good, if users are very savvy or their applications are savvy to create a stripe directory where you're going to put, 1 million files or something like that. You can get good performance. But in terms of, can you set a default layout for the whole, directory layout for the whole file system and get great performance? It's not quite there yet. And so it's sort of the similar problem that progressive file layouts addressed for file sizes, like do you create a 1-stripe file or a 8-stripe file or a 150-stripe file. With directories, if the expense of DNE is if you're doing any kind of cross MDS operation is considerably slower. And so you want to try and stick on an MDS, MDT as much as possible. But when you need the scale, you want the scale. And so what we're implementing is directory restriping. In the current tools, you can do single stripe directory migration. So migrating, typically from a single MDS or a single MDT to, a multi-MDT file system. You could say, okay, I want to move this user, over to MDT2 and that user to MDT7, whatever. You can get static, space partitioning. The directory restriping lets you say, okay, I have this million, file directory, stripe it across, 8 MDTs, right? And so that's a bit of infrastructure. And the other thing that we've done, it actually already landed, is I think it went into 2.11, is being able to have LFS make dir select the best, best MDTs for a given new directory, right? So if you do LFS make dir, stripe count 1, it'll pick the MDT that has the most free space on it. If you give it a stripe count, it'll pick the N MDTs that have the most space on it, right? So it's better than what we had before, which is a fairly static, if you create a stripe directory, on index 2, it'll use 3, 4, 5, right? It had to go in that order just because of the tool interface. But the next thing that we would like to get is that, and this is a little bit more tricky, is having regular make dirs, be able to say, I'm somewhere high up in the file system tree, and if I create a directory, that other MDS is lonely, I'll go over there, and that'll provide a more dynamic space balancing. And then beyond that, we have patches to do some of this already, is dynamically restriping a directory as the directory gets larger, right? So the best performance you get is, local directory on a, local inodes being created there. But once you get larger than, 10,000, let's say, files or so, then you say, okay, maybe this directory is getting a lot bigger. I'm going to restripe it, to 4 or 8 or whatever MDTs. And so users don't have to be savvy to know, when do I create a stripe directory and when don't I, right? You get a little bit of a performance hiccup in the middle of your, directory creates, but then after that, you get 4 times the create rate, assuming, you're being throttled by the MDS in the first place. And then all of the new entries will be created in, multiple stripes. And, so that I think is it's not going to be exactly the same as progressive file layouts, but it's a similar kind of idea to, relieve the user of, the burden of trying to understand the underlying infrastructure. So there's a number of ZFS improvements, and I'll be going into these in detail. But the main thing that, ZFS 0.7 is getting lots of maintenance releases. And the 0.8 actually has quite a number of interesting features that are, going to improve performance and behavior for Lustre users, right? There's, sequential scrub and resilver, which is, checking the integrity of the ZFS storage and rebuilding from RAID, improves the resilvering speed. On-disk data encryption, this is not something that Lustre itself will integrate with yet, but I know last year there was a presentation about having external tools manage the encryption, and something like IML could potentially also manage the per pool keys, and then you have a secure on-disk storage. Project quota accounting already landed. It provides for ZFS the same project quota as went into LDiskFS, a couple of releases ago. Device removal, which is one of the pain points for administrators in ZFS, is once you make one of the common things is you add some disks to a pool, and then you realize, oh, I forgot to say RAID 5 or RAID Z2. Add those disks, and now you have 6 RAID 0 drives in your pool, as opposed to 6 drives in a 4+2 RAID, right? And so you can quickly undo that. If the drives don't have any data in them, it's not very much effort to take them out. A bit bigger feature, metadata allocation class, which I'll describe tomorrow, is optimizing sort of like a mini Lustre inside of ZFS, where you have a metadata volume and then your data volumes. And so you can put the metadata on flash and the data on spinning disk. It's hybrid. I mean, ZFS has done hybrid storage for quite a while, but it was only in read caching that it would do that. And so you had to populate your read cache from the spinning disk before it was on flash, and you didn't have any placement on the creates. And so this allows you to have hybrid storage more efficiently. And then declustered parity RAID is, improving the rebuild speed, as a factor of, the number of RAID groups that you have in your storage. You have 100 drives, your rebuild, might go 10 times faster than, a traditional ZFS file system. So it's a big deal on the recovery side. Quite a number of other small improvements that are, already in flight for the 2.12 release. And so token bucket filter continues to see improvement from DDN. They got a new UID GID policy landed, and so that you can, in addition to the existing thing, job ID, client NID, now you can specify priorities for users directly. A new little feature that was added for job stats, so that you can specify custom formats for job IDs. So in addition to setting the environment variable in your process, or the other static one was proc name UID, right? But now you can say, put in a little bit of a static string, and then the job ID, and then the executable name, and then the process ID, right? Or the user ID, or whatever you want. And then, when the kernel is resolving the job ID to send in the RPC, it fills out the strings, and then it's easier to monitor your per job usage on the server. Dump and restore of conf params, and so this is actually something that people have been asking about for quite a while. Is what of all the parameters that I've set in my file system, and how do I find out what those are? We've had the ability to list those parameters for a while, and maybe since 2.7 or so, you could dump them out in a YAML format, nicely formatted, but we didn't have a way to restore them. So somebody at Cray, is parsing the YAML file now and just builds a set of conf param commands in the background or set param commands, and can restore your tunables, file system tunables, which is quite handy. HSM infrastructure, both Intel and Cray are working at improving HSM integration with coordinator, improving the efficiency there. Lazy size on MDT has its own whole presentation, so I won't get into that one. The T10 PI used to be called T10 diff. It's data integrity verification, so checksumming and things like that. Lustre has for a long time done checksumming, data checksumming over the network, but Lustre's protection of the data started when the RPC was built, and it ended when the RPC, when the data was submitted to disk, right? And so with T10 PI, if you have appropriate hardware on the server side, this will be originally a LDiskFS feature mostly, but the T10 PI is actually supported by, HBAs and drives directly, and so we would be able to, compute the checksum of the data, as soon as it's written into memory on the client. It gets transferred over the network with this using the same checksum. The server verifies that checksum, and then it submits it to the HBA, and the drives, they all verify the checksum all the way down to the platter. And the reverse, we get checksums from the platters, they're stored with every sector on disk, and then we push it all the way back up the pipe with appropriate checks along the way, and so then you can have, integrated end-to-end checksums. And persistent client cache. I don't know, is there a presentation this year on that? Yeah, okay, so won't get into too much. That's, great performance improvements on the clients. James covered upstream kernel quite a bit, so, needless to say, lots of good things going on there and lots of people involved. File level redundancy. So this is a feature that went in, the first phase of which went into 2.11, so it's by no means, complete. I mean, my development philosophy is that, there's a choice between you can wait, 10 years for a feature and then it's complete at the end, but, did it actually meet everybody's needs? Who knows, because we just gave it to you in 10 years. Or you can develop a feature, you can have, small incremental chunks, and they go out in the world, they don't meet everybody's needs to start with, but at least you can start getting a bit of feedback. It might help some users, it might not help everybody, but they wouldn't have been helped anyways if you waited till the whole thing. So 2.11 has mostly infrastructure for file level redundancy. There are some use cases which can benefit from it, but we're continuing that work in 2.12. So these ones are a bit of infrastructure to improve the allocator, so that the MDS is a bit smarter about not putting two replicas of a mirror on the same OSS, because that OSS goes offline, you've lost both copies of your data. It's already smart enough, it's not going to allocate them on the same OST, but it doesn't look at the network topology, and that's some information that Lustre already has, is what's the same NID. There's also going to be an ability to specify, what are the fault domains of various OSTs, so that you can say, all of these OSTs are in the same rack, right? And don't allocate, your replicas from OSTs in the same rack. That needs a bit of input from the administrator. We can't figure that out ourselves, but it's not going to be super complex. Improving replica selection for reads and for writes, then having some topology awareness. So if you had like a burst buffer that's attached directly into your cluster, right, and they're on nodes inside of the cluster network, you'd prefer those ones directly. I mean, you can specify preferred, that's a tunable that exists today, but we can also look at the network topology and say, these ones are close on the network versus these OSTs are far away on the network, prefer the close ones. And that will work too if you have like a WAN setup where you have replicas of your data in two different locations. each of the clients can read from their local replica without having any input. And LFS mirror resync to improve, to allow the clients to mount directly on the OSTs so that, you can avoid a network round trip when you're doing RAID resync, or not RAID resync, replica resync. And one of the other interesting things that I think won't be too hard to implement is a mirror open command, so that you can, just like if you run, your bash commands under the script or something like that, or sudo, where it opens up a, environment for your command to run. If you have LFS mirror open, what it will do is it will allow you to grab your standard input, standard output type file descriptors, and then you can read and write directly into one of the replicas. So it'll be easy to build tools to do resync or compute checksums or whatever, right? And so I think this will be actually quite powerful. One of the other interesting things I think that we would be able to do with the mirror open is to be able to have versioned files. So if you have a replica that doesn't get updated, it's static as of 4 weeks ago, right? Then you can say, oh, let me open up the 4 weeks ago replica and read out my historical version of the file and do a diff or something like that. So you could do LFS mirror open, diff replica 1 versus replica 2, right? And I think that would be quite useful. One of the bigger features that's going on for erasure coding or for FLR is erasure coding of files. So instead of doing straight mirroring is simple to start with. And back in the day when we've been looking at file redundancy for a few years already, it was the prevailing thinking was do all or nothing, and nobody wants mirroring because who wants to mirror their 50 petabyte file system, right? I mean, the storage vendors do, but the customers don't. And but I think mirroring at the Lustre level is useful if you do it at a per file level, right? Because then you can say, these are important, input files, output files, they need to be mirrored. My home directory needs to be mirrored. My scratch files, they don't. But maybe once a day, mirror my checkpoints rather than every hour. And so that if, something goes bad, one of your OSTs is permanently lost, you can still only roll back one day and continue your computation rather than, have to wait for backup to be restored. So FLR, reduces the space usage, from 100% or 200% mirror overhead to, 15 or 20%, 25%, depending on what redundancy you select. And one of the good features of this erasure coding is that you can add it to striped files that exist today, right? So rather than, it's similar to RAID 4 in the sense that you'd have, RAID 0, bunch of stripes, and then you add in, parity for those existing stripes. So the RAID 0 data lives in one component. You add in, 2 parity RAID onto your existing file. And, whether that file was just created now or created 10 years ago, you can add parity to it. So I think that that's going to be quite powerful. Like the phase 1 replication, the redundancy will be built after the file is written so that it doesn't, take away client I/O bandwidth. And, we're not in banking with Lustre, at least I hope nobody's doing banking transactions on Lustre. But, so having redundancy after, 5 minutes after a file is closed is enough, right? It saves you, for the years that file might live there. And, if you crash in the middle of doing your checkpoint's no good anyway. So, having immediate resync, is not something that people were asking for. I did a straw poll at Supercomputing last year, and most people only wanted erasure coding over immediate sync writes. And so this is what we're implementing next. And so, like Nathan had been talking about, I think there's a lot of potential functionality that can be had from composite files. You can do, tiered storage. One of the first things I think FLR would be useful for today is, integration with a job scheduler like Slurm or something like that in your job submission script. You could have the job scheduler, run a small job to mirror all of your files, your input files when they enter the job queue. And then if one of the OSTs goes offline, you can still access your files, when you get to the head of the job queue. And this was actually a paper that somebody at Oak Ridge wrote, I don't know, 6 or 7 years ago about, how many jobs wait for a day or a week, till they get 1,000 nodes in the job queue. They get to the front, and then one of the OSTs is down, they get an IO error, and then they're punted out, right? So the good thing about like the job scheduler integration is that that's a deterministic type of usage of a burst buffer, right? It means you mirror your file at the start of the job, you unmirror it at the end of the job. The clients can actually write into the flash mirror immediately, and then Lustre would resync it from the mirror back to the OSTs, the disk-based OSTs, and then you release the mirror when you're done. And a more sophisticated integration with a policy engine, do you balance, well, like this OST is full, I'm going to migrate it here to a different tier of storage. That needs a lot more integration, but something like Robinhood can do that. And then you can also specify policies, on a per directory basis. Home directories get 2 copies all the time, and your policy engine can add, the mirroring, and then, call into a copy tool that runs, local to the OST to do more efficient data migration. So there were a number of policy engines and scanning engines described at LAD. So I think this is an interesting area that lots of people are doing some interesting work on. Another area that's seen some good work is client efficiency and improved read performance to improve the read ahead. There's some contention about this patch, so it needs a bit more attention. But there's savings to be had there for sure. Disconnecting idle clients from servers, so especially in very large environments, if you have tens of thousands of clients connected to all of your servers, you generate ping traffic, right? And that can be, significant because it's the product of your servers and your clients together. So if idle clients, disconnect after 5 minutes or 10 minutes, right? They don't have any locks on that server anymore. They might not talk, even after several time steps of doing checkpoints, they might not talk to a specific server. And so why keep that connection open? It saves on your ping traffic. It saves on your memory on the client and the server. It also simplifies recovery because you might have, 5% of any clients connected to a specific server at a time. And so if that server crashes and needs to restart, you've sped up your recovery quite a bit. And together with that is aggregating StatFS. So instead of, the client doing StatFS, talking to every, OST in the system, it talks to the MDS, and the MDS is already doing StatFS, every 5 seconds to do space balancing during allocation. So it can just send that information back to the client, right? And so unless you do LFS DF and you want per OST information, the aggregate StatFS is enough. And then there's also some work to reduce jitter by, making some of the wake-ups more synchronized. So if you have, for instance, some of the ideas we have is hooking the wake-ups into like job ID, so that if, a whole bunch of clients are running with the same job ID, that they would wake up and do some, pings or other Lustre processing, all at one time, so that, you don't interrupt multiple time steps of a computation, right? And you don't introduce network traffic that causes jitter, like every millisecond, you run at the slowest possible client speed. This way you'd make one big blip, right? All of the clients go slow, and then the rest of the timestamps go, 5 times as fast, right? And, that has to be balanced with the fact that you don't want all 10,000 clients, pinging one server at a time. It's not going to be good, but, there's room to be had there. Another project, this is a little bit, on hold right now, but there was a bunch of work done for the client-side data compression. And as you can see, I mean, some of the results are quite interesting. Let me see, where's my laser pointer? Here. So they were actually getting, with a very simple, it's called LZ4 fast, they were actually getting, I/O performance that's above the network speed by doing the data compression on the client. And these are tests done by doing, embedding the compression inside IOR, right? But it shows the CPU cycles and everything like that are there, right? And if you do the compression in the Lustre client, you can get good performance. And they were actually working to integrate this with the ZFS on-disk compression, so you didn't have to like decompress and recompress on the server side. The lady who's working on this, she's on mat leave right now, so we didn't want to put it for 2.12. I think that by the time she's back, it'll be ready for 2.13. Another very interesting idea that we're just starting exploration in is client-side write-back caching, so that you can do operations like just in RAM on a client. And so, open, create, write, close would all happen at local RAM speed, and then you flush to the server in the background. And there's actually two different ideas that are being discussed. One is, a per file, write-back caching that integrates very well with Lustre, but it has more overhead, flushing, over the network to the server and from the server into the file system, because every file still has to be, at some point or another, has to be processed, individually. Another idea that we're discussing is having something called a file set, which is just like a LDiskFS image file that's loopback mounted on the client. And many customers are actually already doing this for certain workloads, VMs and things like that. They mount Lustre, LDiskFS image files or ext4 image files, locally into the VM, and it's just stored inside an OST object on disk. But if we integrate that with like auto mount on the client, it would appear like a transparent part of the namespace, and then clients can read, write, create, do whatever they want inside the ext4 file system, and get hundreds of thousands of operations a second potentially, because that's local ext4 speed. And then when it goes over the network, it's chunked into megabyte size chunks when it's going to the OST, right? And so you can create, if you theoretically at least, if you look at, let's say, a gigabyte a second to your OST, which is not hard for a client or an OST to do these days, that's 1 million files a second, right, of just sending the data to the OST. So it's very appealing. There are some drawbacks about it, because how do you manage, like we can expand ext4 file systems easily. You can't shrink them easily. How do you deal with them when they're sparse? When do you create such a file set? Would it be a user command or something like that? It needs more overhead, but it has a lot more benefits. We don't have a good idea of which one of these is the right answer. I think that's it, yeah. I'll skip that one. All right, I think I'm out of time. Questions, anyone?
Questions? So with the write-back cache, client-side write-back cache, do you expect to maintain the POSIX, strong consistency?
Yeah, so that's a good question. I mean, initially, at least, in the prototype, we actually have some prototypes in this area. Initially, it would work best if you have a new directory, right? So you do a make dir, and that directory is empty, you can maintain 100% POSIX semantics, right? The clients have actually had some support for this. Like this is not a new idea. This is an idea that's existed, for 15 years or more, right? And so the clients actually have infrastructure to do this. We've just never, had the, funding or whatever to implement it. And so with new directories, it's pretty easy to do. With existing directories, you could do something like, if it's a relatively small directory, you just do a read dir to populate all of the names into the client dcache, and then you know whether you're creating unique names or not, right? Or you're writing to existing files. So it's actually not very hard to maintain the POSIX semantics. There's a lot more work that needs to be done. Actually, so Oleg has actually done this and, gotten, 50 or whatever, 100,000 creates a second per client, right? But the harder part is, managing, your memory usage, and are you using space on the MDS? I mean, it works with Data-on-MDT in the sense too that you can flush, your small files to the MDT and large ones to the OSTs, but you have to reserve space on the MDT, you have to reserve space on the OSTs, you have to reserve inodes for LDiskFS file systems. You can't run out of memory on the client and suddenly, your client crashes, whatever. So there's a lot of, going from this is a proof of concept to this is a production, but, yes, I think, Lustre does POSIX, so we'll keep that.
So all this redundancy stuff in the file layout's pretty interesting. I'm trying to understand if your model is that potentially we could go to simplified storage systems with like no RAID in the storage. If I mean,
yeah, that's not something that I would not advocate people do that today. No. The reason is that the whole infrastructure around Lustre to do the resyncing and things like that doesn't exist, right? And so, we need to build up the infrastructure either through, copy tools or automated processes that run, to do actual mirroring in the background. I think for most people, you wouldn't want to, the size of OSTs is big enough. You're in the hundreds of terabytes now for OSTs. I think if you lose one disk, you wouldn't want to have to resync 100 terabytes of data, right? So even today with RAID 6, the size of individual disks is high enough that, your silent, error correction is right on the margin. So people are already advocating multi-layer redundancy. So I don't think that we would go, to not having RAID 6 at the storage level, but we could definitely get to, not having failover storage, right?
and then just sort of tied into all that, I didn't see any reference to replication redundancy of metadata. Is there something going on there, or did I miss it?
That's my next slide. But this is more on the speculative, let's call it, I won't say, sorry. I was going to say it's more on the Nathan scale than on the Andreas scale. So this is something we've talked about it, and we've done some, I wouldn't even call them designs, but had several hours of meetings on what needs to be done to get this to work. And the truth is that we don't have any funding to work on it, right? And we don't have enough people to pull off of all the other projects, to work on this. It's something that we could do, and there's, the ability is there, but, because it's, like I said, 2.14, it's a little bit, vaporware at this state. And, I would like to have it, but, the truth is you have 1 or 2 MDTs or 4, you have 100 or 1,000 OSTs, and this is, solid state, and it's mirrored, it's just much more reliable, right? And so you have much, much higher chance of losing OSTs. And so, that's where you got to put your redundancy for now.
All right.